Hey guys, welcome to the 35th C# tutorial that I'm making for the new Boston. And in this tutorial, I'm going to be showing you some more variable types that we haven't looked at yet. So the first variable type that we're going to be learning is a byte. And a byte is composed of 8 bits. And a bit is either a 1 or a 0. The maximum value that 8 bits can hold is 255. So therefore, the maximum value that a byte can hold is 255. Now, 2 bytes put together is called a short. So that would be 16 bits. So I'll just call it my short right here. Just set that equal to 0. Alright, and another way to represent a short is called an int 16. And that's just basically another way of saying a short. So the 16 in this int basically just represents how many bits are inside of it. So it would just be an int 16 or a short. So a 16-bit integer. So I'll just call this int 16 here, set equal to 0. Alright, and since these are both the exact same thing, we could set my short equal to int 16 or int 16 equal to my short. So we just say my short right here. And it's fine because they're both the exact same thing. And the next one, 4 bytes or 32 bits, is the exact same thing we've all been using up until now, which is just the int. That's just a 32-bit integer. It's called my int here and set equal to 0. And another way of representing an integer is just int 32. Let's call it my int 32. And since int and int 32 are the exact same thing, we can just say my int 32 equals my int. And the last one is a long. And a long is basically 8 bytes long or 64 bits long. So I'll just call this my long right now, so equal to 0. And another way of representing a long is an int 64. Let's call it my int 64. And just like all the other ones, since my long and my int 64 are the same thing, or since long and int 64 are the same thing, we can set my int 64 equal to my long. Alright, so up until now, all we've learned is signed integers. And signed integers means we can set them equal to both negative and positive numbers. So since these are all signed right here, we can set any one of these all equal to a negative number. So if we want to set this equal to like negative whatever that is, then we can set this byte equal to anything, right? Well, actually no. This byte is unsigned, and unsigned means that you can only set it equal to something between 0 and 255. So in order to represent a signed byte, you're just going to put s byte to represent a signed byte. So now we can set this equal to negative numbers as well. And now these, however, they're all signed already. So to make these unsigned, we're just going to put a u in front of it to make it an unsigned number. And an unsigned number means that it can only represent numbers between 0 and up. So we can set this only equal to positive numbers or 0. And in order to have an unsigned int 16, we just put a u in front of that, and it now becomes an unsigned int 16. And same with all these. So I have a uint 32, a u long, and a uint 64. Same thing. Alright, the next thing is a float, and a float is a floating point integer. And a floating point integer is used to hold very large or very small numbers. And so to represent a float, you're just going to want to type float and call it something that's called my float. But anyways, you can set this equal to pretty much any size number you want. So you can make it like that. I think that's, yeah, you can set it equal to that, but you can't set like even a long equal to that. So, but the thing with a float is it's only accurate up to 7 digits long. So if we were to display this in a message box, let's say this float, right, create a message box, float. And floats are stored in scientific notation. So they can only be accurate up to 7 digits long. So now when we debug here and click, you'll see it's in scientific notation. Yeah, so it's only accurate up to 7 digits long, which is how long this is. After that, they'd all be zeros. But if you keep something under 7 digits like that, that'll be stored fine, and it should just be displayed normally. Yep. And you can set floats equal to negative and positive numbers, so we can make this negative right here. Be fine. Bug, you get negative, whatever that is. And you can also set floats equal to decimal points, so you can do like 0.5 or something like that, but in order to convert it into a float, we have to use the F suffix just to tell the compiler that it's a float. Now another way that you can store numbers with decimals in them, or numbers less than like 1, you can use a double. So you can just create a new double here. Let's call it D instead of equal to, I don't know, anything. And you can set these equal to numbers with decimal points as well, only you don't need to have the F suffix. So we can just set this equal to like that, and that'll be fine. And the final one that I'm going to be showing you is the character, and this doesn't really have anything to do with numbers, but it just stores a character. So we can just use char, it's the representation for C#, character, let's call it C, and to represent a character in C#, you're just going to want to use the single quote. Let's represent like a D, and we can do that, but we can't represent more than one character in a character, so we can't do like D, 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 no, it's not going to work. We have to set it equal to only one character at a time. So that's pretty much it for this tutorial. So see you guys.